Hey, ciao. Olwele. How are you guys? So my name is Sinalo Jabe, and I started a project. So the project is called Leveling Up, whereby I'm gonna be upgrading my mathematics and upgrading my life sciences, which I'm really hoping that I'm gonna do a good job. And yeah, if you've been watching my previous video, you would see that I was doing some math. There was no life sciences, and it's coming soon. It's coming soon. It's coming soon. Nonetheless, I'm excited for this one because we're gonna be doing the p parameter on the exponential function. We're gonna be talking about is how the p parameter affects our exponential function, and also I'm gonna do a little part of a past paper to just see just how really this will be tested in an exam. So just tune in. And so before we go into that, I want you guys to first hit the thumbs up, hit the subscribe button, and hit the notification button to be notified every time I drop. So without further ado, let's go to the video. Oh, wait. Now before the video, the way in which I show my content is that I just show my paint on it's an application on my laptop, which there won't be me standing here and talking about whatever I'm gonna be teaching. I'm just gonna be like showing it on that application. So if you think I can do a better job, just leave that in the comments below so I can like design my videos and edit my videos better so you can be happy, I can be happy. Cheers. Okay, guys. Sorry. So as you guys can see from the screen, I obviously said we're gonna be doing the p parameter. I don't know why I'm repeating this with it. Anyway, so this is a grade 11 mathematics textbook. Yo, what was that? So okay. So let's see, what does the p parameter do to a graph? Okay. So wait a minute. So there. So if you guys can look closely on this, right? So they say here the effects of p is a horizontal shift because all points are moved the same direction, or moved the same distance in the same direction. The entire graph slides to the left or to the right, you see? So essentially what they're saying like every point on a graph shifts either to the right or to the left. That's what our p parameter does to a graph. It shifts our graph horizontally. So for example, if we have this graph right here, our graph either like the entire thing slides to the left, to the right, or the entire thing slides to the right, to the left. Yeah, so that's how it shifts. That's how it works. So as you guys, I've made something so you guys can understand this a little bit better. So if you guys can see here, so we have two equations of exponential functions. One is given by the equation y is equal to 1 times 2 to the power of x plus 1 plus 0, meaning our graph has no vertical shift. That's why there's 0 there. So now, if we have x plus 1, what does that mean for our graph? Okay, what this essentially means is that our graph has moved 1 unit to the left. That is very important. So how do I know that it has shifted to the left? Okay, so don't be confused. Remember, if we have x plus 1 in the parentheses, what you have to do is say x plus 1 is equal to 0, thus x is equal to -1. That means that our graph will shift 1 unit to the left. The entire thing will move 1 unit to the left. And for the other one, given by the equation y is equal to 1 times 2 to the power of x minus 1 plus 0, this means that our graph has moved 1 unit to the right. Right? Same thing, x minus 1 is equal to 0, then x is equal to 1. That's how we can find the shifting of the graph. So this one, in this side, our graph is shifted 1 unit to the right. So I think it's very easy to see this when you're looking at the table form of like finding your intercepts. So when you find your intercept and you use your table form, you can clearly see how the graph has shifted. So for example, so this one is the original graph where it cuts the y-axis at 0 and 1, okay? Oh, let me make this bigger so you guys can see where I'm pointing. Oh, that's to be, yeah, that's right. So it cuts the y-axis at 0 and 1, okay? And so you can see that when x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 8. Now, what if the graph is shifted 1 into the left? What happens? Look here. Compare this. Okay, no, that's fine. Compare these two things. Compare this, right? And also compare with these values. Look here. It's like the entire thing, the entire values, these values are shifting to the left. Look here. Here, 3 was 8. Now all of a sudden, 3 is now 16. You see, this, it shifts this way. 2 is no longer 4. It's now 8. It's like if we were given, if this was B and this was C. You see, the value of C is now the value of B. That's how it shifted. Anyway, it's easy, bro. There you go. So if you guys want to understand how the shifting works, I think it's very easy to look at the table form of it. Right? You can just see how it shifts to the left or how it shifts to the right. As you can see, 3 was 8, but now it's 4. On the original graph, 2 was 4. Do you guys remember? Again, 2 was 4. It's kind of crazy, bro. The original graph, it was 0 and 1. When the graph is shifted to the right, it's 0 and a half, then 1 and 1. You see, you can see it just how the graph shifts. Anyway, now let's tackle a past paper, right, and see how this can be tested. So there, we're given an equation of an exponential function that has 2 to the power of x plus 1 minus 8. Immediately, it's easy to just immediately know that, this graph has shifted 1 unit to the left, right? We did see this right here. There's it. It's given. With this example, we said if there's x plus 1, we know our graph is going to shift 1 unit to the left, okay? Anyway, so the first question in the graph says, write down the equation of the asymptote of f of this graph. Okay, well, that's very easy. Okay, let's write the asymptote. The asymptote, the asymptote is the line in which the graph never cuts. And I did say this on my previous video. So if you didn't see this, please go watch that video. So, okay, our Q, remember, if you're given an equation, remember our A is 1 right here. Then we have plus our B is obviously 2. Then we're given this, our X, then our P is 1. Can you guys see? Very, very, very nice. You see? So then our asymptote is going to be y is equal to negative 8, okay? To negative 8. But I don't know why I'm writing our q is equal to 8. So the equation of the asymptote, you don't say q is equal to 8. Be careful what you're going to say instead. Okay, let me just use blue. Let me use this blue. What you're going to say is you're going to say y is equal to negative 8. That's the vertical line. No, horizontal line, sorry. But it cuts the graph horizontally. That's there's a equation of asymptote. Obviously 1 mark, so you don't need to stress about that. And now they're asking us in 4.2, like, sketch the graph of f, clearly indicate all intercepts with the axis as well as the asymptote, right? So we're given 4 marks. So as I was doing a lot of past papers, I can see how the marks are distributed. You're getting 1 mark for the shape of your graph. You're getting a mark for the asymptote. You're getting a mark for, what is this now? You're getting a mark for your intercept, and I think you're getting another mark for another point in the graph. Okay, so let's go. Let's answer this question. So we're sketching that graph. I just want to quickly, so we're given y is equal to what? Y is equal to 2 to the power of x plus 1 minus 8. Okay, I will come out now. What's that? Okay, so remember, guys, what I said, right? Remember what I said. In order to grow a graph, what do you need? So there are a couple of things you need. I always say this: when you meet this, when you're given an exponential function, what you want to do is to be able to write this function, want to be able to draw this function. Okay, and so let's go. The first thing we're gonna do, is find the intercepts, right? Sometimes you only have 1 intercept, and other times you only have 2. I'm thinking in this case you're gonna have 1, but I don't know. Intercepts, okay? Okay, for the x intercept, now it's gonna be just crazy. Yeah, but doesn't matter. Oh my god. Let y, I'm gonna just fix this. Don't worry. I'm gonna fix it right now. Okay. For the x-intercept, let y be equal to 0. You're gonna have a y-intercept in this one. So I was lying. Did I say there's gonna be 1 intercept? Oh, maybe I'm not lying. Wait a minute. Yeah, I'm actually, there's gonna be 2 intercepts. Anyway, you let for x you let y be 0. Okay, jeez. Okay. Let's let x y be 0. This is 0. Then this is x plus 1. That is not 8. Okay, I'm gonna have to remove this. Then you take your plus 8 both sides. This is a positive 8. My bad, people. Okay, is equal to 2x. Just so difficult to write with your pad, the touchpad, isn't it? I wish I had a stylus pen. Anyway, we change this into an exponential form, which is 2 over 3 is the same as 8. So we have this. Then you can clearly see, right? You can logically see that the power of this has to be the same as 3 for these two, I don't know what I can call them, for these two values to be the same. That means in this side, x plus 1 has to be equal to 3 for these two values to be the same. Hence why we're going to say we drop the bases. But the reason why we drop bases is because if you can look at those two numbers, it makes logical sense to say, well, 2 to the power x plus 1 has to be 2 to the power of 3. Okay? So what you do, you minus 1 both sides. Oh, it's taking a lot of time, but it's fine, guys, it's fine. Doesn't really matter. I'm gonna be done with this very soon. There we go, we have this is our x-intercept, is 2, Okay, that's not 21, guys. I'm just gonna fix that. It's 2 and 0. Okay. Then what we're gonna do also, we're gonna find. We're gonna find the y, the what? The y-intercept, right? Okay. Okay. For the y-intercept, let x be equal to 0. This is gonna work because there's the p now. P, there's the value of the p. When we don't have, so you know this. So sometimes, remember I said that an exponential function only has the y-intercept. The reason that sometimes it has two intercepts is because there is the value of the p. So whenever there's a p, just know, there's gonna be a y. There's gonna be two intercepts, okay? Oh, wait a minute, I'm talking. X has to be equal to 0. I think my conscience was showing me, that's why I made a mistake there. That's plus 1 minus, oh my god, come on now. Minus 8. I'm trying to be as fast as I possibly can. So with this, we're gonna have, that's gonna be 1 to the 1, then 2 minus 8 is gonna be negative 6. Okay, so there's our y-intercept, which is 0 and negative 6. Who can tell me, guys, if this is an increasing or decreasing graph? How can, do you guys still remember what makes our graph increase or what makes our graph decrease? Remember we said it was the B. The B makes our graph increase or decrease, and our A makes our graph, tells us where our graph is, either in the first and the second quadrant, or okay, let's just make this bigger. So yes, guys, if you guessed it, this graph is gonna be increasing. It's gonna be an increasing graph because our B is bigger than 1. Do you guys remember? No. Yes. It's bigger than 1. Remember we said when our graph is between 0 and 1, then we're gonna have a decreasing graph. However, when our graph, when our graph is bigger than 1, then it's increasing. Anyway, that's the first thing you find. Oh, remember, I'm now confusing you guys. I remember, if you watch my previous video, the first thing you have to find is your asymptote, which is negative 8. Forgive me for that. The second thing is your intercept. And now we will go into like sketching the graph, okay? We sketch the graph. This is our sketch. Let me make it a little bigger if you guys cannot see. Now we sketch the graph. Okay, I'm not gonna finish this entire word. Just gonna take time. It's not gonna be drawn to scale because I'm just trying to hurry up, but it really does not matter. What matters is the values that you give. I know why I did that. What matters is the values that you're gonna be giving. Okay. This is the x-intercept. You're trying to hurry up. This is the y-intercept. Yeah, because I want to do other stuff. So our graph supposed to be bigger because it's negative 8, isn't it? Okay. There's our asymptote, okay, which is at y is equal to negative 8. Okay, negative 8. and then I'm gonna use what color? Let's use green. And so we said the graph cuts our x-axis at 2 and 0. We're gonna say this is 1, probably this is 2. Really doesn't matter, guys, as long as you do say there, you do show the value of that. Oh, right, we don't need another point. We're gonna have 2 marks is for like the y-intercept and the x-intercept. Okay, this is -6. That's probably here. If this is 2, 4, 6, that's over here. Something like this. Damn, don't switch. Okay, don't switch off. Oh my god, I think my laptop is gonna switch off. But yeah, guys, I'm not sure if I'm gonna be able to do the. No, I didn't fart. I did that with my mouth. I did because I made a mistake. Yo, now it's gonna come across as if I farted. Anyway, that's just weird. But what the fuck? Anyway, there's our graph, people. But we just have to indicate that this is at 2 and 0. Okay, come on, stop making mistakes like this, bro. 2 and 0, and then also have to indicate here that this is 0 and -6. Okay, so we have 1, 2, 3, 4 marks for the shape. Okay, that is that. Then I'm gonna do 4.3 right here. If I cannot, I'm just gonna explain it. Right, because it talks about reflecting. I think we have to reflect our graph. Let me see how flat is it first. Okay, and then I cannot. Okay, the graph of G is obtained by the reverse graph in the y-axis, right? The equation. Okay, well, that's very easy. So you find they say this graph has to be reflected about the y-axis. So what is the equation of that? So that's very easy. What you just have to do is to whatever graph you're given, you have to just change the value of x. Okay, just gonna be 2 minus x. Was it plus 1? Was it plus 1? Plus 1 minus 8. There.